All right, guys, so we are going to keep looking at some quadratic characteristics in here today. This lesson is going to be for September 11th and September 14th. Now, with the ACT days the next 2 weeks, the calendar is kind of getting a little bit messed up. So whenever I released the test dates, the B test date was incorrect. The A test date is staying the same. So A classes, so that is second and fourth period, y'all are still going to have your test on September 17th. It is going to be in a Microsoft form again. It is going to have a start time and an end time again. Please, please, please complete this before the deadline that is posted in Kidem. I will upload the test then, and I need it completed before that deadline. The deadline is going to be different for the A test and the B test group of students because of there's like 3 or 4 days in between the taking of this test, because the B day test will be on September 23rd, and that is for 3rd, 5th, and 7th period. So again, that test is going to be on Microsoft Forms. It is going to have an open and a close time. Please, please, please take it. If you are not able to take it during those times, please reach out to me and I will set up a time with you that you can take it. Today, we were going to start working on Mathia. We will be completing Module 2, section workspaces 1 through 4, and those need to be completed by your test again. And some of you are still missing Mathia from the previous test unit. So please finish those. Once you finish them, please, if you are finishing old Mathia, please email me once you have finished it so I know to change your grade. All grades should be updated by tomorrow afternoon at 3:10. So please check your grades this weekend. If you submitted something and there's still a 0 in it for it, I am human. I'm sorry. I'm trying to keep track of everything, but there's at least 20 kids that have emailed me about a grade. And again, I'm trying. I promise I am, but there's about 100 and something of y'all and just one of me. So please check on your grades. And we will also be doing some test corrections. I'm going to post a video about the test corrections from our previous test. I decided that we are going to do them. I know several people reached out to me and I said we weren't, but we are going to be doing test corrections for that previous test. I will send out information about that on September 15th, that first ACT day. And these test corrections are optional. You do not have to do them, but I'm sending the test corrections information out on September 15th, and it needs to be turned in to me by September 22nd. I will not take the test corrections after that. I'm giving you a whole week to complete them, and I will be posting information about that on September 15th. So that can help your grades out if you're struggling with your grades right now. If you have zeros, email me. I think I already said that. But today we are going to keep talking about the quadratic characteristics. Some of this is going to be notes and some of this is going to be practice. Majority of the notes here are kind of review from what we covered in the previous 2 days. So if you have a question, this may help you. This is also a very handy notes page to have because it's kind of all the information that we covered in those 4 pages in one. So this has a little, just kidding, we didn't need that there. If we're looking, it has 1, 2, 3, 4 boxes. So in that first box, we are going to write quadratic equations. So hopefully at this point, y'all have recognized that quadratic equations have that x squared up in there in the corner. That's how we can determine it's going to be a quadratic equation, is that x squared. They look like a parabola. And we're going to kind of write some notes up here kind of about that parabola. So, I'm going to zoom in too. So, if A is greater than 0, that also means that A is positive, our parabola, are we going to fit? Yes. Our parabola is going to open upwards. or up, which was in the other notes. Sometimes a different word helps you out a little more, but if our a is positive or a is greater than 0, our parabola is going to open upwards. So a is less than 0 or a is negative, it means that our parabola, it's going to open downwards. And again, that was in our notes on that first page from the last time that you were in this class. And that was talking about if our parabola is opening upwards and downwards. That was where we got our maximum and minimums from. And I believe most people did fairly well with that in the play Pause It. Let's draw a little graph on here so we can have a nice visual. So if we're looking at our parabola, this point right here, our turning point, is going to be our vertex. And then the line, the vertical line that goes straight through there that we could fold on top of each other, we'd have the same graph on both sides. That is our axis of symmetry. Oh, we're barely going to fit. Perfect. So that's just a little bit about that one. And we'll use an orange pen to kind of section these off. All right, so now we're going to kind of talk about the different forms a little bit. And again, this was on the last note, so this is just kind of a review to help you if you're a little bit confused. So, all right, so the first form we're going to kind of talk about is going to be that general form, or we also called it standard form the other day, but we can also call it the general form. And that was when f of x was equal to a of x squared plus b of x plus c. But kind of the nice things about this one is that it shows us that c value shows us the y-intercept. So as you remember, our y-intercept was 0, c. So the y-intercept is very easy to determine based off that. For our axis of symmetry here, and we abbreviate that with AOS the other day in the notes, we had that x equals that negative b divided by 2a. Don't forget about that negative out here. That is very, very important. I think even when I was in high school, I always thought opposite of b. So if thinking opposite of b helps you there, you can think the opposite of b divided by 2a. So, and we'll do a practice one together in these, and maybe that'll help you out a little bit. So let's kind of section that one off. Let's see, what other colors can we use? Let's go with purple. So the next one that we talked about in class was that vertex form. It is actually my favorite form. So it's when f of x equals a x minus h squared plus k. So very important thing that I pointed out was that minus on the inside. So remember, we got to think opposite for our h values here. It's very similar to the absolute value. If it's inside, we're going to think opposite. If it's outside, we're going to think the same. So the nice thing here is that it shows us our vertex. So our vertex here is that point h comma k. So we would go and we would find our h value and our k value, and we have our vertex. For our axis of symmetry here, it was also fairly easy. It was that x equals h value. And so that one was pretty much what was important there. We'll do green for this last one. So the last one was that factored form. And that was the last one that we messed with in the notes. And that was when we were looking at f of x equals a times x minus p, x minus q. So, and again, with these minuses being in there, we got to think opposite for our actual literal values. So the nice things about here was that we were immediately shown our x-intercepts because it was that p comma 0 and that q comma 0 because our x-intercepts, so our y value is always going to be 0. For our axis of symmetry here, we were looking at x equals p plus q divided by 2. So, and again, very important here with this axis of symmetry and these x-intercepts, you got to think the opposite because it's inside because of that negative there. Okay, so I actually edited my document a little bit. So for that fill in the table, if you want to put your work on an extra sheet of paper, you can, but I wanted to get some extra room on here so that I could explain how I was getting some of these solutions. So I would love for you to pause the video right here and try to figure these out for yourselves. I am going to explain them though, because I know several people are still a little confused on how I was getting some of the values. So if you're confused, definitely watch and see if that'll help you, and then maybe work some of the example problems from the previous homework or from this next one. So whenever we're looking at this y equals 1/3 x squared plus 2x plus 3. So the first thing I want to talk about is that axis of symmetry there. So to get our axis of symmetry, which you can look back on your previous page or in your notes from the other day, to get our x value, we were looking at that negative b divided by 2a, which let's go and write our values up here. So our a value is that 1/3, b value is 2, and c value is 3. These are coming straight from our formula and the forms at which they were written in. So we have an a in front of our x squared, a b in front of our x, and a c as our number out on the end. So whenever we're looking at this, so we can think about negative b or opposite of b, so that'll be negative 2 divided by 2 times 1/3. So you can either type that straight in the calculator if you need to, or you can follow along with me. I'm going to do it by hand. So we're just going to bring that negative 2 over because there's nothing to do there. So we can also look at this as 2 over 1 times 1/3, and those cancel out and end up giving us 2/3 on the bottom. And then if you are ever multiplying or looking at a fraction and there's a fraction in your denominator, I always learned that keep, change, and flip of that fraction in the bottom, and then you can either cross cancel or cross multiply to get your answer. So we're going to get rid of those 2's because we can cancel them out. And our final answer will be that negative 3. So x equals negative 3 is our axis of symmetry. So that axis of symmetry is also giving us the x value of our vertex. So we can go ahead and write that down as well. And at this point is where you then have to plug in negative 3 into that equation to find our y value. And some of the points from the previous lesson, that's a way you can find any point on this graph by plugging in an x value. So we're looking at, we're looking at f of negative 3, which equals 1/3 negative 3 plus 2 times negative 3 plus 3. Oh, which don't forget your squared here, because remember we got to square that negative 3 first. So we're talking about 1/3, and we got to do our exponents first. And negative 3 squared is positive 9 because we are doing negative 3 times negative 3 plus 2 times negative 3 plus 3. And you can pop this in your calculator if you would like, or you can do the math yourself. So if we were to do our math ourselves, we should get that that value is 0. So our vertex is at negative 3, 0. Because our a value is positive, we are going to have a minimum, and our y-intercept is going to be that 0, c value. And our c value here is that positive 3. So let's scroll down a little bit and use the bottom of the page to look at that second equation. So let's change our color. I like that purple. So for our axis of symmetry here, and if you look up on your notes from either 2 days ago or the top of these, our axis of symmetry for this vertex form is when x equals h. So let's actually talk about our values here. So our literal h value here is -5 because we have that positive inside. Our typical form here has that negative. So remember, we got to think opposite. Our k value is that 30, and our a value is that -2. So our axis of symmetry here is actually going to be x equals -5, which is also our vertex x value. And then our k value is that y1. So because we have a negative a value, we are actually going to have a maximum here because our graph is opening down because of that negative value. All right, and so for our y-intercept here, we do not have a c value. That k value is not a c value. So what I recommend doing here is go ahead and plugging in that value of 0, which I'm writing f of 0, but y and f of x are the same thing. So we'll look at -2, 0 plus 5 squared plus 30. Let me scroll down a little bit. So let's go ahead and bring down that -2. 0 plus 5 is going to be 0, and 5 squared is 25 plus 30. So we're looking at -50 plus 30, which gives us -20 for our y-intercept. All right, so if you have any questions about those, I sent out a link for my office hours for a Zoom meeting. So if you have any questions, you need to Zoom in to come into that link. If no one has shown up within the first 10, 15 minutes, I probably am going to go ahead and end the Zoom call because there's a possibility I have students in my classroom or there's things that I can be getting done. But if you need a Zoom call at another time, please, please, please message me. I can Zoom some afternoons, not all, but some I can, or we can set up a day at which I can. So the last little thing that we're going to talk about is some transformations. And these are very, very similar to whenever we were talking about transformations with our absolute value functions, except for these obviously are with the quadratic functions. So it's kind of the same thing. So our values, well, if we're looking at vertex form, which, and let's zoom in, let's look at A. So if we're looking at this vertex form, which actually with all of these, honestly, I would probably just write down your vertex and go from there. Look for your vertex and determine if it is going to open up or open down, and that should answer the majority of our problems. So our vertex here for A, we're in vertex form. So remember our vertex is that HK. Remember we have to think opposite for our H value because it's inside. We have that -1. And since we have a positive A value because we don't have anything out front, our graph is going to open up. Let me zoom out a little bit and see if we can find one that has a vertex at -1, 1 and opens up. So which we do, and that is that number 4. That is right there. So in another way that you could look at this as well is if we're looking at that inside value, we're going to go left 1, and that -1 is going to take us down 1. That's another way you can look at it. So whenever we're looking at B up here, that is in standard form. So we would have to then do our axis of symmetry, so that -b divided by 2a. Let me make this pen a little bit smaller. It may be better to look at. So that x equals that -b divided by 2a. So our b value here is 0. We do not have a b value here, so it is 0. But we do have that 2a, and our a value here is that -1. Now, 0 divided by a number gives us 0. Because our 0 is in our numerator. If our 0 is in a denominator, it would be does not exist. But because we have a 0 in our numerator, we do have an x coordinate of 0. And then to get our y, we would have to plug that 0 back in. So we would have -0 squared minus 1, which would end up giving us -1. So in our a value here is that negative, so our graph is going to open down. So let's zoom out and see if we can find it. So we do have it, and it is this number 8 down here. So this is some very, very good practice on finding your vertex and determining if your graph is going to open up or down. So go ahead and complete those really fast and submit your answers in there. I will go over your answers here in a second. All right, so looking at C, which I'm probably just going to go ahead and do all of my vertex points, and then we'll go and find all of our answers. So my vertex point here is going to be 1, -1, and our A value here is positive, so this one also is going to open up. When we're looking at D, we got to do that x equals again. So we're looking at x equals, and we have our B value this time. So opposite of B or negative B would give us 2 divided by 2 times A, which gives us 1. So our x value here is 1. You would then plug in that x value to get, so you would have x squared minus 2 times 1 and plus 1, which would give us 0. So we're looking at the point 1, 0 for our vertex. We're going to open up again because of that positive exponent. We don't have a negative out there. All right, so over here, we're going to have to do the same thing. X equals negative of B divided by 2A. So this is going to give me -1. When I plug -1 into this, we're going to have -1 squared, which is +1, plus 2 plus 1, which will give me 4. So we will have -1, 4. And that one's going to open up again because we don't have a negative A value. And then back to vertex form, personally my favorite just because it's so easy to find our vertex. So we're looking at -1, +1, opening up. Down here at G, we're looking at +1, -1, opening up. And then this H, you can kind of, let's go ahead and look at it like it's in the standard form. We'll go ahead and do it again. So x equals -B. We don't have a B here. Divided by 2A. So we're going to have 0. When you plug 0 in, you're going to get that -1. And this one's also going to open up. So let's zoom out a little bit and we'll kind of, see if we'll go back to where we were. Where were we? Oh, here we are. Okay, perfect. So let's see if we can match some graphs up here. Okay. So we got A and B, so let's look at C. So we're looking at 1, -1 going up. The only vertex that we have with that 1, -1 going up is number 1, so that is going to be C. For D, we're looking at 1, 0. And the only one that we have at 1, 0 is this 7 down here, and that's D. E is at -1, 4 is what I have, and that's E, which we do not have a -1, 4. Did I do that math right? So we plugged in -1 squared, got 1. -2 would give us -1. Oh, plus 1. That should not be 1, 4. That should be 1, 0. Sorry about that, guys. So -1, 0, that's actually 6 down here, which is E. I thought that 4 was weird. It's probably because I didn't do my math right. For F, we're looking at -1, +1, which looks like number 2 to me. G was +1, -1. Looking like number 3. And H is at 0, -1. So we're able to match up all those graphs there. And then down here, we're going to find the coordinates of the vertex for the parabola defined by the given quadratic function. So just find your vertex and you're good there. So and then for the next one too, you're going to find the coordinates of your vertex. Yeah, so the good things, you're going to find the vertex on both of those. You can go ahead and do that. I am just going to put the answers on here. If you have questions about this, please contact me. It's the same thing. We're just using different values. So This one right here, our vertex is 3, positive 1, not negative 1. 3, positive 1. Here we're looking at negative 1, 5. Down here we're looking at 2, negative 5, and negative 1, 9. All right, so the only other thing that needs to be completed today is your Mathia. Try to get at least half of it done. We will have one more class where we can work on Mathia, but we're also going to be working on our review that day. So we're going to spend half of today working on Mathia and half of another day working on Mathia. So maybe try to get sections 1 and 2 done, or workspaces 1 and 2 done. And that is it, I believe. So yeah, so I'll probably take y'all's Mathia as your homework for tonight. That'll probably make everyone in class very happy as well. Next time you see me, I will be giving y'all a review and some more Mathia. So y'all have a good rest of your day. If you have questions, please let me know.